Hey guys, in this video the brilliant Mr. B is going to be looking at trigonometry and the graphs of trigonometry, taking you through the transformations, what they look like, the shapes, and how you can recognise and interpret them. Now, to go with this, over our website there are thousands of multiple choice questions for you to practice and a ridiculously large workbook for you to download.
We're going to have a look at trigonometric graphs. Now, the first thing to notice here is that I've got 3 accurate graphs drawn out for you, but you might not always have these drawn, and you might actually have to draw that red line yourself. So first, we'll just go through how to create these graphs if you need to. Now, if you don't have a calculator, then you might be expected to remember some of these values I'm about to go through, but sometimes you will have a calculator, and you can use the calculator to help you. So with the Sine graph, sin 0 is 0. So you know you can put a coordinate right there that was drawn in blue. And sin 180 is also 0, and sin 360 is also 0. So we can draw those 3 points. And again, you've got to remember these if you don't have a calculator. If you do have a calculator, that's great. Then you can just use a calculator to check. Other easy ones to remember, sin 90 is 1, and sin 270 is -1. Now, if you're familiar with how a sine curve looks, you can draw the graph just from that now. If you're not very confident, then you might have remembered values like sin 45, and again, you might have a calculator to help. Now, with sin 45, that is 0.7, or just above 0.7. I am rounding. So looking at the axes, we've got 5 sections between 0 and 1. We're going up by 0.2 each time. So going up the side, we have 0.2, 0.4, 0.6, looking halfway for 0.7, and then moving across to 45, we know that our graph has to go through that point. And again, if you're familiar with a sine curve, then you'll know it will also be at the same height on the other side of 90 degrees. So from 45 to 90, we've added on 45 degrees. So adding another 45 degrees onto 90 will get us 135. It's the same thing below as well. So we take 270 as our centre, adding 45 to 315, we'll have a negative 0.7, and taking away 45 from 270, we'll have 225. So that will be our other negative 0.7. And again, it's a little bit above 0.7. I've just rounded that figure to make it easier to plot. Now we've got these points, now we can draw the graph. Now, if you're thinking that's quite a lot to remember, you only really need to remember 3 of these. That's sine 0 is 0, sine 90 is 1, and sine 180 is 0. That'll get you the first part of the curve, and then you can just repeat an inverted version below for the second part of the graph. Keeping that in mind for the cos graph, you need to remember that cos 0 is 1, cos 90 is 0, and cos 180 is -1. And again, with just those first 3 points, you start to get a picture of the shape this graph is going to take, and then you can reflect it for the second part. If you're not very confident drawing the curve, then again, we can go for those in-between values like cos 45. And a good thing with this is it's also going to be 0.7, or rather 0.707, but again, that's rounded. And 0.7 is going to be enough to plot it. So then we go to 135, we can find that 0.7 figure, and then repeat that on the other side of the graph, reflecting all the points across, and then you're going to get a much smoother curve. Now, the tan graph is a little bit trickier. So you need to remember that tan 0 is 0, but then tan 90 doesn't have a value. And that's because the graph doesn't actually hit tan 90. It's going to get closer and closer to 1, but it's never actually going to fit 1. And so I've got a dotted line through 90, which is what we call an asymptote. So the line will gradually approach it. And if I just extend this line, what's going to happen is the line's going to get closer and closer and closer, but it's not actually going to hit the asymptote on 90 degrees. Given that a tan graph is not going to hit 90, we do need to remember that tan 45 is 1, and the line's going to go in between those 2 points. And then you notice the tan graph repeats. So for each time, we're going to have a 1, then a 0, and then a 1. Then moving on to the third section, we're going to have a 1, and then we're going to have a 0. So it'll keep repeating between -1, 0, and 1, and that's clustered around 0, 180, and 360. It's not going to hit the in-between values like 90 and 270, which is where we have a dotted line. So now, if the graph is not given to you, then you should have some idea of how you can start to approach plotting the graph, even if you've gotten a few of the values. So now we're finally going to have a look at question 1 and start to use these graphs. And question 1 says cos 60. So for cos questions, I'm going to label these ones in green. I'm going to find the cos graph, which is the middle graph that we have. And I need to find 60 degrees. Now I can't see that labeled, but these graphs are going up in 15-degree increments. So we look at 45, cos 45, it's going to be one rectangle to the side. It's going to be 15 degrees over. So I'm just going to mark that in green on the graph now. That's where cos 60 is. Now to estimate the value of cos 60, what we do is we draw our line going upwards and we're going to meet the red line. And once we meet the red line, we're then going to come over to the side. And then we've got to try and decide what value we have there at the side. Now, this seems like it's going pretty evenly through that square. So if it's going up by 0.2 each time, we've got 0.2, 0.4, and then a half. That's going to give us 0.5. And it's simple as that. That's going to be our answer. So cos 60 is equal to 0.5. Moving on to question 2, I want to follow the same process. So we have cos 45. So again, I'm going to do all the cos questions in green. I'm going to find 45 on the graph, which is labelled this time. And I'm simply going to trace a line up from cos 45 all the way up to our curve. And when we get to the curve, I'm just going to go across to the side. Now again, remembering this is going up in 0.2 each time, I'm going to count my way up from 0. So for full rectangles, 0.2, 0.4, 0.6, and then it goes again about halfway up. So that's going to be around about 0.7. So for cos 45, I can estimate that it is 0.7. Now, if you typed cos 45 into your calculator to get the accurate answer, what would happen is, so you press cos, you press 45, probably have the 45 in closing brackets on your calculator, and you're not actually going to get 0.7. To 3 decimal places, you would get 0.707. And even that number has been rounded. So it's just an example of we've estimated. We have got very close, and it's going to be good enough for full marks. You won't be expected to get 3 decimal places from graphs like this, but just so you're aware of what the accurate value is. In terms of remembering this number as well, it's a good idea to remember that cos 45 is around about 0.7. You need to plot these graphs. And there's also an exact value for it, which we'll cover in another video. But to write that number without rounding, we can call it 1/√2. And that's an exact value that isn't rounded. Obviously, it's much more complicated to look at and think about. Now, for question 3, we've got sine 45. I'm going to do the sine questions in blue. And looking for the sine graph, it is the first graph. So for sine 45, we're going to find 45, and it is labelled for us. We're going to go up from 45 to hit the graph. And then once we've hit the curve, we're going to go across. Now, you might recognize where we've hit up here. And if we go from 0 and go up in 0.2s for each rectangle, 0.2, 0.4, 0.6, and it's halfway up. So again, it's going to be 0.7. And it is the same value that we found before. So I'm just going to add to the bottom here that all those values are also the same as sin 45. So you do get the same values appearing, and this because the sin and cos graphs are actually the same graph. It's just that it's been moved 90 degrees to the side. Now looking at question 4, we've got sin 165. So again, we'll do the same questions in blue. I'm going to find 165 on the Sine graph. Now, it's not labelled, but I know it's going up 15 degrees each time. So if we go to the one underneath, 135, add 15 is going to be 150, and add 15 again is going to be 165. So it's going to be 2 squares to the right of 135. Now I've made that on the graph, I could draw a line up to the curve. It's quite close, this one. And then we can come across to the side. Now, looking at how high up that is, that looks to me to be about 0.2. So I'll write that down. But what I am going to do now is show you how close I've got with my estimate. So with sin 165, if I type that into a calculator, I'm actually going to get 0.259 to 3 decimal places. Now, that means that this time my estimate isn't very good. I'm a little bit too far away. So how has this happened? So I'm going to go back to the graph. I'm just going to delete my working out. So we should be doing this in pencil. If we have made any mistakes, they're easily corrected. And just make sure using a pencil and a ruler, you're being as precise as possible. And actually, looking at the graph again, I can see that the red line does actually cut through 165 a little bit further up than what I actually did. I got so excited about the first rectangle finishing so close to the red line, I didn't actually notice the red line does actually cross a little bit further up. And so with that in mind, I'm moving across the side. We can now actually see that is tracking to be much more like 0.25, which would be a good estimate. Even though the answer, if you round it to decimal places, would be 0.26. But that's around about how close we want to get. Now moving on to question 5. Now this is tan 225. So I'm going to do the tan questions in pink. And this is our third graph. So I'm going to find 225, and it is labelled. And again, I'm just going to continue this line upwards until I hit the red curve. Now again, I'm in this freehand to show you how I'm tracing the line, but you need to be using a ruler for this. We're going to go across to the side. And what we should see here is actually where it does cross. Looks like it's pretty much exactly on 1. So tan 225, going to write down that that is 1. Now again, I'm going to check that on a calculator just to see how close my estimate is. And tan 225 is actually exactly equal to 1. So we've got a really good estimate there. Now, moving on to the medium questions, we're going to make estimates the other way around. So rather than looking at the degrees and then looking up to the red line to find the value of sin, cos, or tan, this time we're given the values of sin, cos, or tan, and then we're going to move down to find the degrees. And the first one we're going to look at is sine x is equal to 0.2. So we're going to do the sine questions in blue and come over and have a look at the sine graph. Now, if we were doing an estimate, what we would do is we would find 0.2. So given that in between 0 and 1, there are 5 rectangles, each one must be a fifth of distance, so each rectangle would be 0.2. So we're going to come across from the first rectangle up, which would be 0.2. It's quite a short journey to the red line of the sine curve. And if we came down, we're going to come down to this point here. Now, we know that each rectangle goes up by 15 degrees each time. We've not quite hit 15 degrees, so a good estimate might be something like here. So let's write down an estimate of 10 degrees. Now, just like the easy questions, I'm going to actually find an accurate answer for this now and just see how close we got. So if sine x is equal to 0.2, then x to calculator, I'm going to type in 0.2. I'm going to use the inverse sine function, and that should get me 11.5 degrees. Looking at my estimate, 10 degrees, that's pretty close, so I'm happy with the estimate. And if you can't get 11.5 out of your calculator for this, then go and see a teacher for help and try and get a bit of help with this. It might be calculators in the wrong mode, or it might be getting your sin and inverse sin mixed up. So try looking for a second function or an INV button or a shift button on your calculator. Now, you might be surprised to hear that this sometimes can be a calculator question and we're not actually done. And if it's a calculator question, well, I just got an accurate answer with my calculator. Why would I need the graph if I had a calculator? Well, it's because your calculator only gives you one answer, but there's actually more than one answer for this question. If we go back to the graph, if we look at 0.2, you'll notice that it hits the red curve right near the start, but you could continue the line for 0.2 across. And you can see as I continue it across, it's going to hit the curve again for a second time. And we do actually need the answer. Now, estimating this, it's not a full 15 degrees below the 180. That would be one full square. It's a little bit above. So we could estimate something like 170 degrees. Checking that with a calculator, well, we can't because the calculator only gives us one value. So how do we do this with a calculator? Well, we're going to exploit the fact that the sine curves are symmetrical. So if our first hit on the line is at 11.5 degrees, and that's starting at 0 and going up to 11.5 degrees, you'll see the sine curve next hits the line at 180, and it's going to be 11.5 degrees away from the 180 as well. Now this is on the other side of the 180, so rather than adding it on, we're going to take it away. And 180 take away 11.5 is going to give us 168.5 degrees. You might also notice that those two numbers add together to give you 180. And there is somewhat of a pattern there that we can exploit as well. So let's try this again with sin negative 0.5. So again, let's do the same questions in blue. I'll be working on the first graph again. And this time I'm going to look at negative 0.5. So starting at 0, we can go down 0.2, 0.4, 0.6 is too far, so we want to start off halfway down. So once we found where negative 0.5 is, again, we can draw a line across. You can use a ruler for this so you're nice and accurate. And we're looking at where we hit the red line. Now, it's the curve and the grid lines kind of match exactly there. And I'm going to come back to the x-axis to see what the degrees are. And we can see it is one full rectangle below 225. So we'll take off 15, and that's going to give us 210 degrees. If you work that out using a calculator, you'll get exactly the same answer. It does hit the curve exactly on the grid lines, so we get a nice and accurate answer. But again, there is more than one answer for this. So if we continued our line from negative 0.5 and continued across the graph, again, you're going to use a ruler, we're going to hit the red curve for a second time. So going up to the x-axis, we can see that this is to the right of 315. So we can add on another 15 degrees to that, and that's going to give us 330 degrees. Now, these don't add up to 180 this time, but there is a pattern here, and it's that 210 is 30 degrees higher than 180, and 330 is 30 degrees less than 360. So always keep your eye out for little patterns here that can help. Next, we'll look at question 3, which is cos x equals 0.9. So we'll colour code our cos question in green again, and this is going to be the middle graph. Looking for 0.9 then, we know we're going up by 0.2, 2 each time. So let's count up from 0, 0.2, 0.4, 0.6, 0.8, and then it's going to be halfway up. So it's going to be right near the top of the graph. Again, we're going to draw a line across to the red curve, and then we're going to have a line to the x-axis. Now, looking at where we hit the x-axis, it's a little bit more than a full rectangle away from 45 degrees. So we can take off a full 15 degrees to get 30 degrees, and it's a little bit more than 30 degrees down. So let's go with 25 degrees as our estimate. And again, that is not going to be our only answer, because again, if we continue the line all the way across, again, you're using a ruler to be nice and accurate. I'm just tracing it out by hand so you can see the process where I'm looking. We're going to hit the red curve. We're going to come down again. Now this time we can see that we're a full rectangle ahead of 315. So adding on 15 will give us 330. And it's a little bit further again. So why don't we go for 335? And you'll notice as well that my estimates do add up to 360. So a little bit of a pattern going on there as well. Now, this one genuinely is an estimate. I know question 2, it was pretty much exact on the grid lines. This one isn't. So I'm going to show you this with a calculator now. So if we had cos x is equal to 0.9, if you typed 0.9 into your calculator, and the version of cos, no matter how your calculator does that, the answer you're going to get is 25.8 degrees. Now, looking at my estimate, which was 25, that's pretty close, so I'm very happy with my estimate. But again, your calculator only gives you one answer. It's not going to give you the second answer. So what do we do? Well, we can see that at 25.8 degrees, that's 25.8 across from 0. We can see that the diagram is symmetrical, and we can see we're coming down near 360 on the other side. So if you did 360 take away 25.8, you're going to get 334.2 degrees. Now, again, that's pretty close to my 335 estimate. And again, you can see these two numbers do add up to give you 360. So find that second value. It's all about knowing your graph and knowing how to exploit the patterns, the symmetry of the graph to find the other value. Moving on to question 4, we have cos x is equal to negative 0.8. So again, we'll colour code this in green. We're going to come over to the cos graph, and starting at 0, we're going to go down 0.8. So going down 0.2, 0.4, 0.6, and 0.8, 4 rectangles down. I'm going to draw a line across. We're going to hit the curve, and then we're going to go to the x-axis. Now, for the estimate, we can see that we're about half a rectangle across from 135, and these rectangles are around about 15 degrees. So why don't we add about 7 degrees onto that? And that'll be about halfway. So 135 plus 7 is going to be 142 degrees. You can even go exactly for the middle if you wanted to and add on 7.5 and have 142.5 if you like. Again, you need to recognise that there's going to be more than one answer, and if we continue our original line, negative 0.8 across, there is a second place where the curve intersects our estimate line. We're going to bring that up to the x-axis as well. This one is about half a square below 225. So again, we take off about 7 from that. 225 take away 7 is going to give us 218 degrees. And again, we've got a pattern going on where those two numbers do add up to make 360. So that's work for question 1, where they both added up to 180, and question 3 and 4, where they've added up to 360. Keep in mind, it doesn't always work, and question 2 didn't actually add up to something like that. Now, this wasn't the exact question, question, it could be a calculator question again, so let's have a look at the calculator version. So we have cos x is equal to negative 0.8, and you use your calculator and the inverse of cos on negative 0.8. The answer you're going to get is 143.1 degrees. So again, you're only going to get one answer from your calculator. So how do we find our second value? Well, as I mentioned, these are adding up to give us 360. So we do 360 take away 143.1. That'll give us our second answer, and that is 216.9 degrees. And looking at my estimates, I'm not too far off, so I'm fairly happy with my estimates. Now we'll have a look at the final medium question, which is tan x negative 0.6. So we'll colour code our tan questions in pink. We're going to move over to the tan graph, and we'll look for negative 0.6. So that's going to be 0.2 for 6 downwards, 3 rectangles down. We're going to draw a line across to the tan graph, the tan curve. Now it looks like we're lining up the grid lines pretty nicely here, so we can go straight up following the grid line, and we can see that we're 15 above 135. So 135 plus 15 is going to give us 150 degrees for our estimate. Now, while tan is a different sort of graph to sin and cos, which are kind of similar to each other, there still is going to be two answers. And so we're still going to have to continue our line and look for the second place where we intersect the graph. Once we hit the curve, again, we're going to go up to the x-axis. And this time we can see that we're one full rectangle to the right of 315. We're going to add 15 onto 315, and that's going to give us 330 degrees for our estimate. And then looking at these two numbers, they don't add up to anything special, but there is a gap of 180 degrees in between our two answers. So answers on the tan diagram, they're always going to be 180 apart from each other. Now, although it looks like that's a precise answer, I'm going to check this one on a calculator because I want to check a tan question on a calculator. So tan x was equal to negative 0.6. And if you type that into your calculator, for your answer, you're going to get x is equal to negative 31 degrees. Now that is completely different to the answers that I found. So what on earth is going on here? Well, let's look at the question. The question says, use the graph to estimate solutions between these and 360 degrees. Now that's something that normally kind of setting up the parameters of the question, not something that's usually relevant, but in this case it is because that negative 31 degrees is not in between 0 and 360. Now, where is this coming from? Well, if you imagine that the tan curve continued downwards below 0, then you're going to get a third answer from our line there. And if you think about it, these graphs can continue on forever in the positive and negative directions. So there are actually an infinite number of answers. And so we need to limit it between things like 0 and 360, so you only get about 2 answers. So what the calculator's done is it's given us the closest answer to negative 0.6, the closest answer to the kind of start of the graph. But we don't actually want the closest answer to the graph, because that's negative, it's outside our parameters. We want the next two answers up. So how do we calculate the next two answers? Well, like I mentioned with our estimates, the kind of pattern in the tan graph is that it repeats every 180 degrees. So what we do is we just add on 180. So negative 31 plus 180 will give us 149. And 149 plus 180 will give us 329 degrees. Now we check our estimates. Although it looked like we had some accurate answers, we are actually 1 degree off. But even so, they're pretty accurate estimates, so I am happy with those. When we write down our final answer, though, it's very important that we do not write the 31 degrees and negative 31 degrees down, because while it is a valid answer, it's outside of where we've been asked to have the solutions. We've been asked right at the start, they have to be between 0 degrees and 360 degrees. And negative 31 degrees is outside of that, so we're not going to use it. And it's fine to have it in your working out, very good idea to have it in your working out with some extra marks, but we don't want it written in our final answer. Moving on to the hard questions now. And the difference here is that the numbers are not as rounded now. We've got things like 333, we've got negative 0.54. So we've got a little bit more detail to the numbers that we're using. A little bit harder to read them off the graph. So question 1, we've got sin 205. So we're going to look at the sine graph for this. I'm going to find 205 degrees, and again we can see this isn't actually labelled on the graph. And if we go to the nearest one, which is 180, if we add 15 onto 180, we get 195. And if we add 15 onto 195, we're going to get 210. And 210 is still a little bit too big. So what we're going to have to do is where 210 is on the graph, just look a little bit below. And you can use 180 as your reference point and add on 15 a little bit more. Or you can use 225 as your reference point and take away 15 to 210 and then go a little bit further down. Obviously this isn't accurate, but is an estimate. So now we've identified 205. I'm going to come down to the curve. Now, make sure you don't stop as soon as you get close to the curve. Make sure you're hitting the curve exactly. Then we're going to go across to the y-axis to read off a value. Make sure you use your ruler for this bit. And we can see we're just over 2 rectangles down. Now, each rectangle is 0.2 because 5 of them are going to make up the 1 we see at the bottom of the graph. So just over 2 down would be something like, make sure we write negative because we're going downwards. 2 rectangles down will be 2 lots of 0.2, so 0.4. And then I do think it's a little bit above, so maybe we'll put a decimal place on there and say something like 0.41. Now, using the calculator, the accurate answer to this is actually negative 0.42. So that's quite close as an estimate, so I'm happy with that. Looking at question 2, we have tan 333. So we're going to come across to the tan graph. Now again, 333 won't be labelled. The closer we can get, I suppose we can start at 315. One rectangle to the right will give us 330. I want a little bit more than that for 333. I'm going to go down to hit the curve, and we're not exactly on the grid line, we're just after it. Again, make sure you use a ruler. Don't stop when you hit the red line, make sure you're on the full-on intersection. And again, very important to be using a ruler here. I'm just doing this freehand just so you can see the direction I'm looking in and where I'm working towards. Now I've hit the x-axis, I can see there's 2 full rectangles down and then nearly a full rectangle again. Looking at my line though, I don't think that's perfectly straight. I should be a little bit further up there. So I think it's going to be around about halfway down. So that'll be a 0.2, 0.2 and a half, it'd be a 0.1. So I'm thinking we've gone down probably about 0.5. And I'm happy to go with that because it is an estimate, so it's okay if I'm a little bit off. Now, again, if we did that with a calculator, we'd be getting negative 0.51. So I am very, very close with that estimate. If you're good with your exact values, you might remember that tan 330 is equal to exactly negative a half. So given we're 3 degrees above that, you might just want to put an extra decimal place on just to be a little bit more accurate, but negative 0.5 will be absolutely fine as an estimate to that answer. Moving on to question 4, So question 3. So now we're looking at the other kind of question, and we've got sin x equals 0.94. So let's do this on the sin graph in blue. Again, going to be a little bit harder to find this number for the hard questions. So 0.94, we're going to go up in 0.2, so 0.2, 4, 6, 0.8. We'll go halfway up the rectangle for 0.9, and then about halfway up again for 0.94. So we're right near the top. We're going to use a ruler to go towards the curve. And then when we hit the curve, we're going to come down to the x-axis and see what value we've got. Now, to me, this one looks like it's about a full rectangle below 90 degrees. So we take off 15, and 90 take away 15 is going to give us 75 degrees. Now, remember, there's always two answers for these, at least between 0 and 360. So we have to continue our original line across and come down. And it looks like we're a similar distance away from 90 on the opposite side. And that makes sense because these graphs are symmetrical. So if our first answer is 15 below 90, our second answer is going to be 15 above 90. And that's going to give us 105 degrees for our estimate. But what we do take into account is that these could be calculated questions. So let's have a look at the calculator version. So on a calculator, if sin x is equal to 0.94, we would use inverse sine on 0.94 to get an angle. And what we should be getting for the angle is 70.1 degrees. Now, looking at my estimate is 75, so I'm just under 5 degrees out. I can't say I'm too happy about that, but you're going to have on exam papers, you have a larger graph. You'll be using more accurate tools, a pencil and a ruler, so you should be able to get a little bit closer yourself. Now, we have two answers, and my calculator has only given me one answer. But as we kind of saw with our estimate, it was 15 below 90. Our other answer was 15 above 90. Now, this one is nearly 20 degrees below 90. So our other answer is going to be 20 degrees above 90. So that's going to give us 110 degrees. But we're just going to remember we've got that 0.1 there as well. So it wasn't quite 20 degrees. It was really 19.9. So it's not going to be 110 degrees, it's going to be 109.9 degrees. And again, think about patterns on these graphs. We see that 75 and 105 add up to 180, and the 70.1 and 109.9 also add up to 180 degrees. So 180 take away 70.1 is going to give you your second answer. Now moving on to question 4. So we have cos x is equal to negative 0.54. So we'll do this one in green, and we're going to do it on the second graph on the cos graph. Now again, the 54 is going to be a much harder decimal to locate on the graph. So we're going to go down 0.5 first. So 0.2, 4, and 5 is about halfway through the next rectangle, and then a little bit further again for the 0.4. Once we've found that, we're going to use a ruler to move across the curve. And again, keeping in mind, we have two answers, so you can draw your line across and hit both parts of the curve that intersect. Now, these intersections look pretty close to the grid lines, maybe just a little bit above. So we'll have one here, and we'll have one here. Now, the first one looks to be just under 15 degrees away from 135. So 135 take away 15 will give us 120. And I think it's a little bit before that. So let's say 121 degrees. Now, the second one looks like it's just under 15 degrees above 225. So 225 plus 15 is 240. And just before that, let's say 239 degrees. And a last bit of checking our answers. On a cos graph, those two numbers are going to add up to give us 360 degrees if the answers are in between 0 and 360. Now looking at the calculator version, and let's see how close my estimates are. So cos x is equal to negative 0.54. If you type that onto your calculator and do inverse cos for negative 0.54, then you should be getting 122.7 degrees. Now I had 121, so that's 1.7 degrees out. I think that's fairly close, so I'm much happier with that estimate than I was with my estimates for the Sine question. Now again, we don't have our second answer, but we do know they should be adding to 360 degrees. So 360 take away 122.7 will give us our second answer, which is 237.3 degrees. Again, looking at the estimate, that's 1.7 degrees out from 239. So again, very happy with my estimates for that question. Moving on to question 3, tan x is equal to 0.67. So we'll highlight the tan graph in pink. Find the tan graph. And I'm going to try and find 0.67. So starting at 0, I'm going to go up in 0.2s, 0.2, 0.4, 0.6. Now halfway up will be 0.7, so I'm just a little bit below that for the 0.67, so around about there. Using a ruler, continue line across, and don't stop at the first intersection. Make sure you hit the curve at both intersections. If we did continue this all the way across, you can see that we're getting nowhere near a third intersection, so there are only 2 intersections available in between 0 and 360. So where the curve and our estimation line intersect, we're going to go down and we're going to hit the x-axis. Now, our first estimation here, it's not quite a full square below 45, rectangle. Each rectangle is 15 degrees, so it's a little bit above 30 degrees. So let's say something like 32 degrees. Then we need to look at our second intersection. Now this one looks like it's not quite a full rectangle below 225. So 225 take away 15, again each rectangle has a width of 15 degrees. That's going to give us 210. So a little bit above that, let's say 212 degrees. And I'm also taking into account that on the tan graphs, they should be 180 degrees apart. Now I'm going to check how accurate these are on a calculator. So if tan x is equal to 0.67, we type that into our calculator and use inverse tan. The calculator should give you, for your first answer, 33.8 degrees. Now I estimated 32, so I'm within 2 degrees, so I'm happy with that estimate as well. How do we get our second estimate? Well, like I said, on a tan graph, everything is 180 degrees apart. So add on 180, and that should give us, for the second answer, 213.8 degrees. Now, the last thing to notice with this is I've said a lot of things like our sin values adding up to 180 if we're in the first part of the curve, or our cos values adding up to 360, our tan values being 180 apart. Are you expected to remember these? Well, it's obviously helpful if you do remember these little patterns, if you remember the symmetry in these graphs, but if you can't remember them, you can always look at the graph yourself and figure it out. As long as you're aware there's a pattern, you're aware of the symmetry, you can work it by looking at them. So for example, with the Sine graph, you can see that the curve is repeating every 180 degrees. So there'll be some kind of pattern around about the 180s. With the cos graph, you can see that the curve's repeating every 360 degrees. So again, you can think, well, maybe 360 has something to do with the patterns. And with the tan graphs, you can see that they're repeating every 180 degrees. Now, it's a little harder to see, but you can see that we're crossing the x-axis at 0, 180, and 360. So you can kind of see that 180 pattern in where we intersect the x-axis. So try and remember them, but don't panic if you forget them, because by looking at the graph, sketching it out yourself, maybe even using a calculator to derive the values. If you've forgotten the values, you can always figure out the patterns in the exam if you really need to.